Hi guys, today we're going to talk about the blockchain and Bitcoin. Now, what is Bitcoin and what is the blockchain? Well, let's dive right in and see. The blockchain is what drives the value of Bitcoin. Now, having said that, how does it do it? Let's ask ourselves, how do you create a digital currency? When you think about it, a file, if we were to represent money with a file is easy to copy, to edit, and to delete, and it has no intrinsic value. It's not ideal. What do we expect from money? What is money supposed to be? Well, initially, money was gold. Gold is rare, difficult to find, it doesn't rust, it's a limited resource, and it's useful or pretty. It's basically the complete opposite of what a file is. But then we started using paper to represent gold. And then that representation between paper and gold, that link, broke. Now we only have paper. And the value of the paper that we have is based only on the trust that we have in the institution that prints it. Money has become fiduciary. It's been based on trust and trust alone. Bearing that in mind, what is Bitcoin? Bitcoin is a digital currency, but where does its value come from? Its value comes from the blockchain algorithm. This blockchain algorithm was described in 2008 and implemented in 2009 by some guy called Satoshi, who claimed to be born in 1975, who claimed to be Japanese, but that person has never been found. We don't know who that person is. And that person, if it is one person, not a group of people, now owns in excess of $44 billion worth of Bitcoin. What is Bitcoin? Bitcoin is digital gold. What do we mean by that? It's hard to find, its value doesn't degrade with time, its value doesn't rely on trust, it's not a fiduciary value, and it's anonymous. How does a program do that? Let's start by looking at the first problem that money needs to solve. It's the double spending problem. If Alice was to say to Bob, here's one, and if she were to copy that message and send the same one to Chris, here, I'm giving you one of money, whatever. Because we're talking about digital currencies and digital signals, it's very easy to copy data. But how do we solve this problem? Well, what we do is we store all the transactions in a shared public block of information, a file that's shared among computers of a peer-to-peer network in a block of 1 megabyte of data. And with this, we have some metadata. And then we secure this information so it can't be tampered. How do we secure this information? Well, imagine that there's a function which can take any text input and that produces an output, a number that looks as if it's not random, but isn't. Now, what do we mean by that? Well, the easy thing to explain is that it's not random. It's a given input always gives the same output, but you can't work out the input given the output. And two very similar inputs give two very different outputs. And the output covers all the ranges of possibilities, and the distribution of the outputs is flat. There are functions that have been proposed to try and do this, and these are called hash functions. And hash functions cut up the text and combine it and do XORs and stuff like that and produce a number. The numbers that MD5 produces, MD5 is one of the hash numbers, are between 0 and 2 to the power of 128 minus 1. SHA 256 does this between 0 and 2 to the power of 256 minus 1. Once again, that corresponds roughly to 10 to the power of 77. That's 1 with 77 zeros after it. Now, let's get back to our blocks. How are we going to secure the blocks? Well, in the metadata, we have a bit of information. We have a link to the previous block, and we also have the version number of the algorithm being used. And we have what's called a nonce, which is just a variable basically that starts out at 0. And what we do is we test this block with a nonce at 0, and we test to see what the hash is. And we test to see whether the hash is below a certain threshold. Let's say we want to test this if it's below 1 million. That means there's one chance in 1 and 69 zeros that it is below 1 million, which means there's a very low chance that it is. So what we do is we increment the nonce from 0 to 1 and we try again, and from 1 to 2 and we try again. And although it's very unlikely to manage to find a nonce which fits the threshold that we've set ourselves, if we commit enough computers and enough time and enough electricity, then eventually one of them comes up with a solution. And this is what we mean by the nonce being a proof of work. It's very easy to check given a block that it's valid, but it's very difficult to find the nonce which has the value which sets the SHA hash to a low enough value. And this hash that's easily computed is what is used to provide the link to the previous block. In a sense, we have not only one block, but we also have a stack of all the blocks, all the previous blocks. And each block represents loads of work and energy and computing power and money being spent to find this hash. And the more blocks they are, the more work it requires to edit the past, to change a transaction that was 10 blocks away. If it's 10 blocks in the past, then it means that you need to recalculate all the blocks since that block is there, which requires more computing power than the network has. The longer the stack, the more expensive it is to start editing the past, because each of these blocks is the sum of a lot of energy and power and computing power being spent to try and validate the blocks. And these blocks that are all connected together, this chain of blocks, this is why the algorithm is called the blockchain, because it's made up of a chain of blocks. And now the one interesting thing to note is that the node that finds the hash, which solves the block, which allows it to be validated with a low enough threshold, that node is rewarded with 1 Bitcoin. And this is why Bitcoin is like digital gold. It's hard to find, it's limited, it doesn't degrade with time, its value doesn't rely on trust, it's not fiduciary. It relies on the expense of a lot of work and energy and computing power. I hope that was clear, that it was useful, that it allowed you to understand better how Bitcoin has its value and how blockchain works. In any case, I had fun, at least, creating this video and explaining it and researching it. Feel free to leave a like, feel free to subscribe if you want to keep learning more about cryptocurrencies, about tech in general, about how tech works. Feel free to subscribe. See you in a later video. Bye.